Hello everybody, today we are going to be doing the homework absorption, light, blood, and oxygen. We will discuss problems 1 and 2. Alright, so for the first problem, it reads, at 660 nanometers, the molar extinction coefficient of oxygenated hemoglobin is 319.6 centimeters. M is moles per liter. For hemoglobin, it is 3,226.56 centimeters. At 940 nanometers, the molar extinction coefficient of oxygenated hemoglobin is 1,214 centimeters. For hemoglobin, it is 693.44 centimeters. For blood, the concentration of hemoglobin is around 150 grams of hemoglobin per liter. Assuming an approximate molecular weight of 64,500 grams per mole for both hemoglobin and oxygenated hemoglobin, calculate the highest absorption coefficient in centimeters from among these values. Alright, so what do we know? From the problem, we know at 940 nanometers, the molar extinction coefficient for oxygenated hemoglobin is 1,214 centimeters. Hemoglobin is 693.44 centimeters. At 660 nanometers, the molar extinction coefficient for oxygenated hemoglobin is 319.6 centimeters. For hemoglobin, it is 3,226.56 centimeters. We also know, for blood, concentration of hemoglobin is 150 grams per liter. Molecular weight for both hemoglobin and oxygenated hemoglobin is 64,500 grams per mole. Alright, sorry, I'm an amateur at this. We are trying to find, quote, the highest absorption coefficient, quote, from the given values above. We will use the Beer-Lambert law, which is found on page 77 of the manuscript, and that is absorption equals molar extinction coefficient times concentration. So from the known values that we just discussed, we do have the molar extinction coefficients of each. We do not have the concentration, and we are trying to find the absorption coefficient. Oops. All right. So next we need to find the concentration. This constant should be the same for both hemoglobin and oxygenated hemoglobin. We already know blood's concentration of hemoglobin is 150 grams per liter. We also know the molecular weight of hemoglobin is 64,500 grams per mole, stated here. So if we were going to go ahead and multiply and convert what we have, we end up with 150 grams divided by 64,500 grams. This leads us to 0.002326 moles. In my calculations that are coming up further, I round this to 0.0023 moles. Okay, so this means the concentration of hemoglobin in the blood is 0.002326 moles per liter. Now we can solve for the absorption coefficient by using Beer-Lambert law. Absorption equals coefficient times the molar extinction coefficient. We have both the concentration and molar extinction coefficients. Now all we have to do is solve for A. Alright, so I did this 4 separate times, so it is a little redundant, just to make you guys aware. So for the absorption coefficient for hemoglobin at 660 nanometers, I use the equation A equals E times C. So I plugged in the molar extinction coefficient, which is 3,226.5 centimeters, times the concentration, which we calculated, which was 0.0023 centimeters. And when you plug that into your calculator, you should get approximately 7.421 centimeters. Excuse me. All right, so for the next value, I calculated the absorption coefficient for hemoglobin at 940 nanometers. So using the same equation, I use the molar extinction coefficient, which was given. It was 693.44 centimeters times the concentration, which will remain the same throughout all 4 calculations. And and the absorption coefficient I received for that one was 1.595 centimeters. Keep in mind that we are trying to find the highest absorption coefficient. That is why I did it 4 times. All right, on to the last two. So I did the absorption coefficient for oxygenated hemoglobin at 660 nanometers, plugged that in like the first two calculations, and received an absorption coefficient of 0.73508 centimeters. I also did it for the oxygenated hemoglobin at 940 nanometers using the same equation, and got 2.7922 centimeters. So now after all these lovely calculations, we can determine the highest absorption coefficient is 7.421 centimeters. This occurs when hemoglobin is at 660 nanometers, and this was the first calculation we did together. All right, on to problem 2. Problem 2 reads, the absorption length or penetration depth is 1 over the absorption coefficient, or L equals 1 over A. The intensity equation can be written in terms of penetration depth as intensity equals I naught times 10 to the negative x over L, where x is the path length through the substance. Calculate the absorption length for oxygenated hemoglobin at 940 nanometers. All right, so what do we know? We know the absorption length L is equal to 1 over A. A is the absorption coefficient. We solved for these in problem 1. Oxygenated hemoglobin at 940 nanometers yields an absorption coefficient of 2.7922 centimeters. All we need to do is plug A into the formula, L equals 1 over A. All right, here I have done this, so L equals 1 over 2.7922 centimeters. Plugging this into my calculator, I did get 0.358141 centimeters. So I didn't do any rounding just in case if Flip It Physics had some issues, as we've all experienced. All right, so the absorption length is 0.358141 centimeters, and that is the answer. Thank you so much for watching. Have a great day.